Hi everyone. In today's class, we're going to look at how to apply solutions to something like water. Water is one of those resources that we take for granted on Earth, and as a first world nation, I think a lot of us also take for granted something that is pretty much available to almost everyone that lives in our country. So I know that this is a different format from what we're used to. Um, I usually give this particular presentation during our all period days, and usually I give you an activity to kind of promote how difficult it is to get clean water sometimes and what kind of restrictions are in place. So obviously we're not going to be able to do that all period day activity, but there is still some important information from this particular uh, lesson that I want to share. So we have spoken about the universal solvent before, and I think a lot of you guys still remember that water is technically our universal solvent. It is a very, very special molecule because um, we tend to think of it as a molecule that gives life on Earth, or at least it's a molecule that's very important um, in making different types of solutions because of its properties. So water is one of those substances that can naturally dissolve almost any solute, okay, thus earning the title of universal solvent. So most solutions that we are familiar with involve water in some way. So because water is very important, okay, um, it also means that a lot of things that we don't want to be dissolved in water will tend to make water polluted. Okay, so clean water versus polluted, nasty, dirty water. That's basically the subject or topic for this entire lesson. So we're going to take a look at what is found in our natural water, okay, and what's found from tap water, as well as what some people around the world may be drinking in terms of their drinking water. Okay, so let's start with tap water. When you go to the kitchen or go to the bathroom and you want to get some water to drink and you drink from the tap, this is the list of stuff that you'll probably find in most Canadian households. Okay. Chlorine is the number one dissolved substance that's found in tap water. Okay. The purpose of chlorine is to kill pathogens and bacteria, so things that make us sick. Fluoride is also added to water since I believe it was the 50s or 60s, and this was to help people prevent tooth decay and forming cavities. Now, this is a list of the natural minerals that you find in tap water. So you get some arsenic, some aluminum, some copper, lead, mercury, and cadmium. Some of these metals are non-toxic to humans, and some of them are actually quite toxic to humans. But they do exist in small quantities that generally don't affect us too much. Another type of substance are nitrates. Okay, so nitrates are things like NO3s, okay, and sometimes NO2s. They're basically just nitrogen containing compounds that we get from fertilizer that seeps into our groundwater. Now, depending on where you're living, if you are living on a farm um, and you're drinking water from some old pipes, okay, there is a possibility that hormones from your fertilizers can seep into groundwater. And then when this happens, hormones tend to have a negative effect on humans, okay, especially if it's in your drinking water. In addition to hormones, pesticides is also something else that can also seep into the groundwater, okay, and basically anything that seeps into groundwater potentially can have the ability to seep into tap water. Now, depending on water facilities, most of these hormones and pesticides are removed, but small trace amounts can still be present. So let's look at what you might get from drinking groundwater, or better known as well water. So if you have a cabin somewhere and you don't have actual plumbing and running water, and you have to get your water from the well, well, here are some things that it might contain. You have a pretty good chance that it would contain some microorganisms. So these would include pathogens, so organisms that can cause disease, bacteria, which may or may not cause disease, protists, or parasites. So if you look at the image below, okay, you'll see a whole bunch of microorganisms. These are mostly protists and bacteria that are basically found in well water. This is also very likely if you drank lake water or river water. So when you're going swimming or enjoying the day in a non-chlorinated pool, right? Natural lake water will also contain a whole bunch of protists as well that you're taking into your body. Other than organic materials, you also find some elements, such as heavy metals. So things like lead or uranium, okay, really heavy, toxic, radioactive metals, okay, can naturally get into well water through seeping into groundwater as well. Now, your natural minerals that you find in well water basically are dissolved minerals from rocks that are nearby. So if your area contains hard water, okay, if you've heard of that term, all that means is that particular type of water contains more minerals than soft water. Nitrates, again, are still present in well water. They often don't get filtered out. So if you basically dig a well close to a farm or any agricultural site, you'll often get nitrates, hormones, and pesticides as well. Now, some of you guys prefer drinking bottled water opposed to tap water or well water. So let's look at bottled water as well to see what is dissolved in them, because there are actually a few different types of bottled waters. Most bottled water, okay, especially if it's called mineral water, will have trace minerals of iron, chlorine, copper, zinc, calcium, and magnesium. Depending on the process that companies use to create their bottled water, okay, if they go through a process called cation exchange, then what they're trying to do is they're trying to remove some of the negative ions from water by adding in positive ions to neutralize them. Now, most of you guys have heard of distilled water. Distilled water is probably one of the cleanest, most pure form of water that we have. When you distill water, you are removing pathogens and heavy metals. You are boiling and then filtering and recondensing that water. Now, I think some of you guys have heard of this story. I kind of remember telling it to one of the two classes. Now, if you only drink distilled water, that's a terrible thing. Distilled water it has a really odd taste. Okay, it's not like tap water or even regular bottled water that you're more familiar with. If you give a baby distilled water, since distilled water doesn't have any minerals, okay, it sometimes causes minerals from a person's teeth, okay, to be extracted. And when that happens, it makes your teeth weaker and less like teeth, because teeth are just mineralized substances. So if you're constantly drinking distilled water, it's not a good thing. Okay. One of the reasons why we do tend to drink water is because we do want the minerals from water, because that is healthier for us, because humans also require minerals in their diet. And then finally, some water bottle companies will use reverse osmosis. This is just a fancy way of saying that you're using pressure to force water through a membrane or a special filter, okay, that basically removes any of the contaminants that are usually present in groundwater or even tap water. So if you're using something like a Brita filter, okay, Brita filter usually just removes odors, okay, it will cause the water to taste a little bit better, okay, and some people that are very used to filtered water, they can really tell the difference between regular tap water and filtered water. Okay, so there's a nice little compromise with Brita filters because it doesn't remove all ions. Okay, they do leave some choice minerals left in your drinking water. Now, there's a huge list of materials that can be dissolved in polluted water, but most of the time when we look at polluted water, they seem a little bit more opaque, and that's because of the undissolved materials. So in terms of things that don't dissolve in water are microorganisms. Anything that's considered to be a large particulate or a large particle, okay, tends to be undissolved in water, polluted water as well. So we're looking at things like animal feces, so solid wastes, petroleum, industrial solvents, runoff sediments, okay, so mostly particles that are found in soil that get washed up into the groundwater, organic debris, and garbage. Now, in terms of things that are dissolved in polluted water, those are generally heavy metals, detergents, pesticides, drugs and hormones, acids, ammonia, which is a base, urine. Oops. Let's go back. Okay. Urine is quite common. It doesn't have to be from humans. It's mostly from other animals that basically pee in, lakes and rivers. So eventually, if you're just drinking polluted water, some or all of these things can be found contained inside of them. All right, so for this slide here, you don't have to write anything. Actually, there's a whole series of slides here that you don't need to write it down. I would just invite you to listen, and I'll basically tell you when you can resume writing your notes. So, water is a very dominant global issue right now. Okay, it's been so for the last 10, 20 years. Okay, but over the last decade or so, it's gotten more and more of a, it's become more and more of a topic. Okay, and people in your generation are basically taking on this challenge in terms of making sure that there's enough water for your children. But right now, our water supply is a very fragile thing. Okay, we can easily run out of clean, drinkable water. So if you look at this little diagram here, back in the 1950s, okay, and this is a global record of how much water is available, okay, by country. So in the 1950s, okay, Africa seems to be the only continent that has severe issues with drinking water. By 1995, you can see that there are more areas that are now affected in terms of their water supply. So the more dark areas that you see, the worse the situation is. So it was projected that in 4 years, by 2025, most of Africa and Southern Europe, okay, and Asia, our water supply is going to be quite low. Okay, even in the United States, North America, we are starting to see that kind of problem as well. One of the reasons for that is that even though our planet is totally made up of water, only about 2.8% of all the water on Earth is actually fresh water. Now, if we take this small little section of this entire pie, and we looked at what makes up our fresh water. Well, more than 75% of our fresh water is trapped in glaciers. Okay, so that means the 25% that's left, okay, less than 25%, is basically drinking water. So this is everything from water that has melted, water in our rivers and lake systems, okay, water that is trapped underground as groundwater. This is the only accessible water for us. So as we look at the entire world, this map here shows how much access to water people on Earth are actually able to access. So what we're looking at are the lighter areas. So in Africa, there are many, many places that basically cannot get access to drinkable water. Whereas in first world nations, okay, that's not as much of a problem. However, in the future, okay, our access to drinkable water is going to be affected. So that's why people are speaking up now, and they're trying to act now. All right, so we can continue on with the notes from here. I've talked about Winnipeg's water supply before in the previous lesson, so I'm just going to quickly go over some main points. Now, most of you guys do know that we get our drinking water from Shoal Lake. Shoal Lake is technically not in Manitoba, but it's over in Ontario. Since 1919, the city of Winnipeg has a contract or agreement, okay, with the reservation on Shoal Lake in Ontario, okay, so that we have access to that body of water for drinking. Okay. Now, one of the reasons why that particular site is picked, because it's in a higher elevation than the city of Winnipeg. So water does drain down, okay, due to gravity, so that it cuts down on cost for the city. So in Canada, drinking water is not a property that is charged for. Okay, so we don't charge people for water. When your parents pay the water bill, what they're paying for is basically the transportation of water, the storage of water, and the treatment of water. Okay, but water itself is not something that we charge people to have. Okay, so like I said, Shoal Lake was chosen because it's a large body of fresh water that's basically in higher elevation than Winnipeg. Okay, so that cuts down on the cost of delivering water to the city. Now, just because Winnipeggers have access to water doesn't mean that everyone in the province does. So when we look at the rest of our province, Manitoba does have a low low rate in terms of people not being able to access water, but that rate is still at 51%. Okay, so that means half of Manitobans still don't have access to water. Okay, in Manitoba, there's about 63 First Nations, and 32 of them report that their drinking water is not drinkable. Okay, in that case, they will have a water advisory. This is mostly because when you're further up north, there are lack of roads, there's no proper infrastructure, there's even politics that are involved that make it difficult to get water out to the people that are living out there. So a lot of the times, if there's a water advisory in northern Manitoba, it means that something has happened to their water supply, okay, that makes it contaminated and undrinkable. Okay, or at least it's unsafe to drink their water. So what they end up doing is they either have to boil their water in order to cook it or use it for cooking or for drinking, or they buy bottled water or waters in these jugs, okay, because that would be clean water. So one of the other problems, though, is because if you're living up north, okay, um, almost everything costs a lot more than what you would expect if you're living in the city. So, for example, in the city, the regular cost of a 4-liter container of orange juice can range anywhere between $5.99 to $6.99. But up north, okay, because it's difficult to transport goods up there, the price of juice, okay, for the same container that you pay $5.99 and $6.99 for is now $26.29. Milk, okay, is also doubled in cost. So if the average or regular cost of milk is anywhere between $5 to $6, up north it's about $10 or $11. Now, water is the next one. Okay, if we were to buy a pack of bottled water, a 24 pack, it can cost us anywhere between $6.25 to $8. But if you're up north, they could potentially sell it for $83. Okay, this particular image, okay, this particular price is probably one of the higher ones that I've seen. Okay, and often it does depend on whether or not there is a water shortage or not. And if there is, water can cost for $83. Even when there's water available, okay, the price of bottled water is actually still normally higher than what we would normally pay in the city. So because sometimes tap water is not available, water is very expensive to buy when water is needed, and everybody needs water. So as a result of all those costs and the lack of infrastructure, 67% of First Nation communities appear to have basically third world or developing world type conditions for their drinking water. Okay. And that's a pretty sad statistic, because there's no reason why people in Canada shouldn't be able to access water, even if they live in remote areas. Okay. With our technologies, we should actually be able to provide water for everyone. So in the next couple of slides, I believe, we'll take a look at how water is used around the world. Okay. Okay. So of course, don't write this down. Okay, just follow along. So if you were a person in the United Kingdom and you had to carry home all their water in 2-liter bottles, okay, how much water would you need per day? 4 bottles, 20 bottles, 75 bottles, or 90 bottles? Well, on average, a person in the United Kingdom uses 150 liters of water. Okay, that is equivalent to 75 2-liter bottles, which is about this much. Okay, so we put them into these 2-liter bottles so that it's easier to visualize how much water is actually present. Because when I tell you that there's only 150 liters of water, okay, yeah, a lot of you would think that's a lot of water, but when you actually see how many 2-liter bottles that actually is, that is a lot of water. So let's do the same thing, but with the US. How much water would the average person in the United States use every day? So on average, you would require about 575 liters of water. So using the same image, this is the amount of water on average an American uses each day. Now, if we go to a more foreign country, in Bangladesh, this is how much water it would use. Okay, so 46 liters of water per person per day. Okay, this actually doesn't seem as bad, right? It seems reasonable. It's only 46 liters of water. Now, if we go to a poorer country, okay, in Ethiopia, in Africa, they only use 15 liters of water per day, which is this much. Okay, and if we even go to a more poorer country, Mozambique, again in Africa, they would only use 4 liters of water, or just two 2-liter bottles. All this water here is how much water they have for living each day. So this includes laundry, it includes drinking water, it includes cooking water. They only use on average 4 liters of water per day, okay, compared to what the US and the UK used. So the World Health Organization basically says that everyone should be able to at least use 20 liters of water per person per day. Okay, this is the minimum amount that is required to do for basic hygiene, for cooking. Okay, if you're doing laundry, if you're bathing every day, okay, you might require a higher amount, but in general, for all your basic needs, it's about 20 liters. So obviously, in first world countries, they're using, like we're using, much more water than we need. Okay, and areas that are developing or third world countries, they don't have enough water even for basic hygiene or basic food hygiene. So what can we do? Okay, well, one of the things that we can do is try to stop wasting water. Okay, we should try to help countries that are not able to get clean water. And one of the ways that we can help is we can donate money to help them with their infrastructure. Okay, donate money to figure out how they can filter water for themselves. Okay, because a lot of the water that they use, when they travel to the water source, they have to carry water back because there's no pipelines, there's no plumbing, there's no infrastructure to bring water back to their villages. So people actually have to travel back and forth every day carrying water, okay, that's basically polluted, so that they can use. So if we can figure a way to filter the polluted water, okay, so that it makes it drinkable, that would actually go a long way to helping them out. So usually in this particular lesson, I would get you guys to do an activity in terms of developing a water filtration device that is able to filter their dirty water and make it a little bit cleaner for them to use. Okay, so obviously we're not going to be able to do that, okay, with the time that we have, but the message is still clear. Okay, in order to help the world with our dwindling water supply, we need to develop new technologies to help clean the water that we pollute, and perhaps to reduce the amount of water that we actually use. So water that goes down our sinks, okay, that goes down our drains, again, a lot of it does get cleaned and recycled, but there's a certain portion of that water that is never cleaned, okay, that gets pushed back into the environment as polluted, dirty water. So the best way to make sure that we have enough water is to make sure that we don't waste water, okay, and that we continue to help people in other countries, in other situations, to clean their polluted water so that they can basically educate themselves a little bit better, okay, and to provide them with the basic needs that every human should have on this planet, and that is access to water. All right, that's all I have for today. Thank you very much for listening.